Alright, so you should be familiar with greatest possible error of a measurement now. It's how far off you could be and still round to the given measurement. Now we're going to look at the percent error of a measurement, and the first thing I want to do is recall a couple things. A percentage is simply a part divided by a whole. So in our case, the percent error, let's write it like this, the percent error is going to be the part divided by the whole. So the whole is the measurement, whatever the measurement is, right? The part, since we're looking for percent error, the part is the error, the greatest possible error. So you're going to take the greatest possible error and divide it by the measurement, and that's going to tell you how far you're off as a percentage, which lots of times is more useful than just the greatest possible error by itself. Let me illustrate this by using two different measurements. The first measurement, 270,561 meters. The precision is 1 meter. Therefore, the greatest possible error is half of that, how far off you could be, 0.05 meters up or down, plus or minus if you want. Okay, let's come down here. Sorry, let's make this red. Let's come down here and do the same thing. The precision is 1 meter. The greatest possible error is 0.05 meters. So notice that these two measurements have the same potential error, the greatest possible error. However, it makes sense that this measurement is much better than the second measurement because this number is so big and I'm still measured to the same precision, or I still have the same error. So this measurement is much better because it's bigger than this one, but it still has the same error. And you can see that when you calculate the percent error. So the percent error equals, up here, it'd be the greatest possible error, 0.05 meters, divided by the original measurement, 270,561 meters, which is, notice that meters cancels, and you're going to get a decimal out of this. And it looks like you get point, and I'm going to count my zeros, 1, 2, 3, 4, 5, 6 zeros, I think. 184, okay, with no unit. If you want to convert that to a percentage, you have to move the decimal to the right 2 places. So you end up with 4 zeros here, 0.0000184%. So that's your percent error, very, very small. In this case, your percent error is going to be your greatest possible error divided by the measurement, which is 27 meters. Meters cancels, and you end up getting, for your percentage, well, your decimal number is 0.00 approximately 185, and when you convert that to a percentage, move the decimal, you get 0.185%. Still low, but not nearly as low as this percent error. So this measurement here is better because it's bigger and measured to the same precision and yields a smaller percentage error. So you can see that here. Let's calculate another percentage error on a measurement that involves fractions. So let's look at 3 1/4 inches. The precision here is 1/4 of an inch. It's how the smallest unit that this tool can measure. So it must be 1/4 of an inch given this measurement. Therefore, the greatest possible error is half of that, which is 1/8 of an inch. That's how far off you could be. And so the percent error is the 1/8 of an inch divided by the measurement, which is 3 1/4 inches. The units cancel. As a decimal, this equals 0.03846, etc. When you convert that to a percentage, you get 3.846%. So your percent error is 3.846 in this case.